This is a Mercedes 220 SE built in 1965 in November. It has mechanical fuel injection. The manufacturer's designation is W111. And the project for today is to repair the clock. Here's the clock. It's a VDO. It hasn't worked for quite some years, so I thought I'd have a go at getting it going. To get it out, I've taken the front off the glove box and just allowed the leather for the glove box to go forward enough to get my hand in behind. Now, to get it out, there's metal clips, springs that hold it in position, so it just pulls forward. The reason I needed to get in behind is that the electrical plug doesn't have enough cable to allow it to come out, so I put my hand in and unplugged that first. And on the side there are just spring clips that latch into the side of the fascia. On the back of the clock there are 3 electrical connections. This one is the earth, and then there's a positive that goes to the light, and there's a positive that goes to the winding for the clock. The power to the clock, of course, is constant, whereas the power for the light only comes on when the ignition's turned on and the headlights are turned on. To remove the cap, there's 3 small nuts. There's one there, here and here, and this one has a plastic cap that seals it. So I presume that's to indicate whether the clock's been taken apart before. So you have to break the seal on that to get that off. So the nuts unscrew, obviously, and then the cap lifts off. There's the globe. There's the connection for the globe. And the way the clock works is that there's an electrical connection that goes to a set of points. There. And the reason the clock wasn't working was that the fusible link had broken. It's on a little arm, in there, and it's spring loaded, so when the solder melts the little arm moves away from the contact and breaks the power. Just to get this tested, I've tied it together with a piece of wire, and then I've put a fuse in the positive side, because if the winding gets damaged, then the clock's not repairable. I've connected the clock to a 12-volt battery, and it does run, but it's running fast and it doesn't keep running. The way it works is that the coil winds the spring, and the contact you can see the contact closing, and it rewinds the spring. That's the spring in there. Winds it on this peg. Now the reason that the clock's not working, or doesn't keep working, I think, is because of dirt in the gears. So I'm going to attempt to take it apart and give it a clean, put some new oil, and see whether I can get it to go. The adjustment is this screw here. When you turn the adjuster, I can get the screwdriver on, it moves that plate, and I don't know whether there's something missing, because the little arm that attaches to the plate has a hole through it, but there's nothing attached to it, so whether there's a spring or something missing from there, I'm not sure. There's a small brass peg that's attached to the adjuster arm, and I think it rubs or contacts with the spring that controls the escapement. So as you rotate the adjuster, it moves the brass peg along the circumference of the spring and presumably adjusts the tension on it to adjust the timing. To adjust the clock, you push the adjuster in the center in, you depress it, and it allows the hands to be disengaged from the drive and move to the correct time position. Now I'm going to start to pull this apart to give the gears a clean. I'm going to start with this spongy piece on top. The next step is to take this plate off, and obviously it's secured with these 3 small bolts. It would appear that what's attached to that plate is the coil. So these are, I've got a 5mm spanner. I'll just slacken these off, maybe hold the plate down to take the nuts off. And then I just undo this third nut and lift this piece off like that, and as you can see it's pretty dirty. This is the fusible link which I've temporarily attached with a piece of wire, so I'll have to get some low temperature solder, 100 degrees, and try and resolder that, because if it needs to separate and it doesn't, it's going to wreck the winding. I've realized that the top layer of the clock, this is the power unit obviously, and the only connection between this and the clock windings is this little pawl just here, and that engages on this gear here and powers this gear, which powers the rest of the clock. So the pawl forces that gear to rotate, and the energy from that transfers through to the rest of the clock. So if I put a little bit of rotational force on that, you can see the clock starts to work. So as the contacts make contact, that pawl flips back along the teeth and starts another cycle of pushing around in a clockwise direction. The next step is to take the next plate off, and these little nuts require a 4.5mm spanner. So I'm just going to slacken all these off, and then that one's loose. Possibly if I hold this plate down and take the nuts off, something on the threads at the end make it a little bit harder to turn. Now I'd expect when I lift this plate the gears are probably going to go everywhere, but we'll see what happens. So I'm just going to gently ease this off. And now I can get in there and clean all the gears. So the dirt on here, or the old grease, it's really waxy and it's quite difficult to remove. So with these gears you can see that there's quite a bit of dirt accumulated in there, and I'm going to have to clean all of that out. Got a piece of wood, just go from one tooth to the other and clean out the dirt. All of the small holes that mount the gear pegs have to be cleaned out. There's quite a bit of dirt in these holes, and the best thing to use is something like a toothpick. When you see the amount of dirt on these gears, it's no wonder that it stopped running. So I'm going to have to just clean every gear individually, as well as the bearing points on the end of the gear. I've had a rethink on how the adjuster mechanism, the time correction mechanism, works, and why it wasn't working on this clock. So that wheel there connects with the escapement, and the adjuster is this pin here, and that moves if you turn the control from the other side. And in this case, the spring was on this side, of the pin, and I think maybe it's meant to be on this side, which is where it is now. There's a wire just above the pin that's supposed to retain the spring behind that pin. So I'm assuming there's no other reason for that wire to be there other than to keep the spring locked behind that pin. How it came to get out from behind, I have no idea. I have no idea how long it hasn't been in the correct position, assuming that my assumption is right. But as that adjuster moves, it changes the length of the spring, in effect, which will change the timing of the escapement. Now it's time to try and put the whole thing back together. The first thing to do is to oil all of the points where the pins go through. Just a tiny drop of oil, except for the jewel, which I think is this one here, where the escapement runs. Now when it comes to clock oil, oils ain't oils, and most of the ordinary oils like sewing machine oil, WD-40 or inox, are actually too thin. So unless you want to spend a lot of money on various types of clock oil, the best oil to use is a medium grade engine oil. And it's easier to oil these plates before you put them together, particularly these little wells. These little wells that will retain some oil. And this one. I think that's all of those. The various gears can now hopefully go back into the spots where they belong, which is a very fiddly job. I've put the next plate back on, and now the tricky bit is to get all of the pins lined up in the holes at the same time. In theory, some of the pins should be longer than others, so they can be introduced first. I'm going to put the nuts back on, just to put a little bit of pressure on the plate so that it will, once the pins line up, they should drop in. The thread on these nuts is only at the top, so they have to go in this way up. Okay, so we've had a disaster. This, I think, is called a verge. It engages with the escape wheel, and it's the bit that you hear go tick-tock. The shaft through the middle is the arbor, and the little pins on the end are the pivots. And being too rough, I've broken the pivot off this end. It's very fine, and if I measure it, it's actually 0.2 of a mil. This seems like an appropriate stage to finish episode 1. Give me time to see if I can locate a replacement part, and stand by for the next exciting episode where hopefully we'll get the clock going again.